Hi guys, welcome to another video. We started trying to do a video, ended up having to cancel it. We had quite a lot of problems with Emacs, and the main reason why we had a lot of problems with Emacs was because we attempted to create log files with megabytes worth of columns, and that seemed to have caused Emacs to go a little bit crazy. I reported all of that here in my issue, so it's the best part of an hour. A bit of a spike, but we're back up and running. So what we achieved in the previous video that never was we made a dump. Let's see if I can go back to logs. We managed to make a dump of the model just before it was used by the locator. I go to locator. Not open yet. Let's have a look. Make sure we're recording, which we are. If I go here and look for locator, there it is. Sorry. Right, if I go to locator here, we made a dump of the entire physical model just before locator kicked in. Now, if you remember, the problem we were having was we could see that the paths being created didn't really make a whole lot of sense. It seems like we're missing both the top level parts folder, as we call it, and it was also missing the facet folder. So that kind of seemed to imply the configuration being supplied to locator was wrong. So we did a dump of the entire physical model to see if that would get us anywhere. And what that gave us was a bit of knowledge of what was going on, but it didn't look too bad, if I'm honest. So if I go back to this enumeration that we're trying to get to the bottom of, here's the archetype for the enumeration, and here's the backend. Facet properties, as you can see, it's populated as you'd expect, and well, we're not using the part property, so it seems like whatever is getting into this chap here looks alright. And then for good measure, if we have a look at the project path properties, they also look vaguely correct. So we think that whatever is getting to the locator is correct. Trouble is, we're still creating the wrong path. So now then, we will continue to look at that log file, but we are dumping some stuff here in locator. So let's just see if locator gives us some other clues. What we'll do is we will look at a sort of a subset of the log, just focusing on locator, and hopefully that will give us some tips as to what's going on. You see here, immediately we start to see some problems. We don't seem to be creating a real facet path, really. So if you look at this facet path here, if you look at the facet path, it immediately seems so. Making facet path for registrar, then making facet path for registrar, and it just doesn't seem to have anything on it. And then done making facet path for features initializer, and that seems to have something on it. So it seems to me as if the project path something is not right here with the paths, right? Bit of an understatement, I guess. But so the project path looks correctly, the output directly looks correct, although we are not typing output correctly. Those paths look correctly. So let's see what happens when you're trying to make a facet path. Make facet path. So what do we do then? We obtain the meta model properties, we obtain the project path property. Now we know these two things look vaguely correct. So what do we think is happening then? If So if the facets directory is not empty and disable facet directories, and not, so clearly we made a mistake here, and not disable facet directories, so we probably should append. Then we go to the internal modules. Another interesting thing, we go to internal modules on the provenance, presumably. No, this is the internal modules of the thing we supplied, so that's fine. Choose the N, okay, cool. Then what we do is say, if the postfix is not empty, so we take the postfix of the archetype, then we take the postfix of the facet, then we take the extension. Now, what is extension? Something is supplied as a parameter. Right, cool. So, what exactly happens if we fix... Oh, actually, while we're here, let's look at the facet path temp. Clearly, that's going to have a similar problem. Let's try that again. Right, so let's see if this gives us any wins. This is part of our investigation here, trying to get Emacs to go a bit faster. And didn't really take us very far. Okay, so now then. Okay, things have improved dramatically. Now we have facets. Okay, that's good. So that was part of the problem. Now the second part of the problem is we don't seem to have the parts attached to the name, and the reason why we don't is probably quite obvious. We are using the project path here. It should not really be the project path. So let's have a look at how this is composing itself. Somewhere where we start with a path, the best thing to do in this sort of cases is to just get whatever we have in head. Sadly, Emacs seems to love putting this at the bottom instead of on the side. Right, so if we just have a look at the make facet path, let's just very carefully see how we obtain the path. We start with nothing. We take the facet directory. But of course the problem won't be directly with the facet path, really, is we have to look at who calls the facet path. Right, so make the inclusion path prefix, really. That's kind of going to be the interesting chat. Right, so what is this chap doing? It's basically saying model modules, so let's just make sure we don't call this MMP. Start off with R. We should just call this model modules, just to avoid confusion. So the inclusion path prefix, okay, that's probably not the worst thing of all. You need to continue to look for where facet path is being used. So for example, make full path. This is a classic case here. Let's just look at how we make full path. So make full path to include directly. Where is, so for starters, we start off with headers project path. Now what exactly is the headers project path? Not clear. In this particular case, the headers project path was computed, so we appear to have created one. Let's see how. compute the headers path. And here we have an output directory project path. Okay, that all looks very sensible. Here we just have a PM. How is that working? So we start off with the MetaModel projects with the project path properties with the headers output directory. This seems to be the problem. We are using the MMP's file path. Now, we really should have used yes, so this is where the problem is going to begin, really. So there's this notion of a headers an output directory path, and there's the notion of a file path. And somebody should really have computed the file path for us. Now if I just go back to our log, and if I look at that JSON that we had a second ago, I suspect it's gone now, but we can compute it again. I suspect the file, no, actually I am quite wrong. The file path is being computed correctly, and it is, as one would expect, the same as, yes, that is absolutely correct. So this looks very good actually. So the file path is being computed. So basically what we're trying to say is, if you did not give me an headers output directly, please take this chap here. So that's fine. So to me it seems like the headers path is being computed correctly. So that means we can ignore that and focus again on the full paths. So we start off by making inclusion path prefix. No, this is just the inclusion path. We don't particularly care about the inclusion path. Let's just not lose track of where we are. Headers model path. Headers model path. Okay, fine. So it has to be one of these guys here that is not quite working right. Now we know for sure, sorry, I'm just struggling a little bit to concentrate here. We know for sure that the project path properties is correct. So one would expect to see include directory, source directory, templates directory. Those look all very correct, okay? So then all we need to do is to make sure that when we're computing an include directory name, we take the include directory name from there, which is fine. Source similarly. Okay, so all these guys look fine. So now the question one has to ask is, did this function get called? So to make a relative include path, I am taking whether it's for include statement. I did not touch this code, but however R has changed, it's just moved around a little bit, that's fine. So to the layperson it seems this is fine. So the relative include path is fine. So let's focus on the full paths then. That looks alright as we checked. Then we have split mode. But did we fix, perhaps the problem is split mode is not quite right. Bingo, so this is the problem. Okay, now you see these errors are so easy to introduce. Now let's just look at how this error got introduced here. Ridiculously annoying. So as you can see here, we are computing the project path, but we have a different variable here, which is the CPP headers output directory path. So there's two different variables. There's the place where we're going to place the headers, and there's whether that directory is being filled in or not. However, here we change the semantics here by saying there's only one variable that we care about. Now that's not going to work. So what we need to do instead is to say, well, let's see if split mode is a constant. Probably is a constant if I'm honest. Yeah, it is a constant. We basically need to compute whether we're in split mode or not. And to compute whether we're in split mode or not, well, we don't need to compute as such, but we need to go quite a lot of places. We need to go to the project path, meta model, properties, project path. And in here, we will have a headers output directory. That's the person, that's the guy that we're interested in really, not the other guy. And by looking at the end result, we change the semantics completely, because there will always be an header output that path directly. So that changed the semantics completely. That was the first bug. I don't think, sadly, this is the last one. But this is definitely going to cause a lot of problems, particularly when it comes to header files. Okay, so we're still struggling. Now the next problem is, well, the same problem really. We still haven't got includes or source in the files we're generating. So let's try to then figure out why. Why is it, in fact, why do we say there instead of path? Well, let's try to understand what would cause the full path to inclusion right, so make inclusion path C++ headers. So now then, this is a classic case where we're creating C++ header, we're calling make inclusion path. Make inclusion path is calling make a facet path. And make a facet path is where we were a second ago. So we spotted the first problem. Now let's continue. Now what would cause the include or the source to be added here? So we should really have something really obvious here, like include directory name, shouldn't we? So yes, that's exactly where we were. So if you're not in split mode, we should just include the include directory name. Now we know for sure that the include directory name is being populated correctly, so that looks fine. However, this is not the only place that we do this. So for include statements, make relative include path. So let's try to understand what this thing means. It's very difficult to keep your head straight because there's so many calls that make calls. Alright, so this is for include statement. Clearly this is not so easy. Let's just make sure we know why I'm doing this. So make full path to include facet directory, make full path to include directory, which we believe is correct, and then make a relative path, relative include path for the facet. And so we think up to here everything looks alright. So the best thing to do really, I mean this is becoming increasingly difficult to follow through all these combinations of calls. We could ask something really simple. We could basically say, we start off with an empty path, we then ask for facet directory name. No, sorry, I'm getting a bit lost as well. What I really want is make a full path when you start getting to this point where you're just very, very confused, what I find very useful to do is just try to see if you can break down the problem. And so one way to do that is to try to log a lot more. So what we'll do is just say show so if we say something like R, we can simply say R is equal to this, and then we can then say else R is equal to that, and then we can simply say the headers of is equal to all this. Return R. And you see, by taking this approach, I mean, we don't necessarily know exactly everything that's going on here, but we're just going to go through all these functions. We don't necessarily need to have all the facet properties for the facet. Probably should really, but let's just say that we're going to have several layers to this. We first start with the easy one. And the other thing we're also going to do is we're going to basically say, don't bother outputting all of this anymore, because we will trust that somebody else is outputting all of this. As you can see, all these methods already started outputting some of this stuff, so the only thing we probably want to do is, actually, let's just go back to where a second ago. Yeah, okay, so we probably want to output anything that was not computed, so the output directory path, because those we're not calling a function, so we're not going to log. So let's just say we output that chap, because everything else we know for sure there's going to be one of these guys somewhere. So if we just very carefully start outputting some of this stuff. Project path. So right now in here we know for sure we are outputting. We don't even know about a generic string. I'm just going to output the path. What we really want to do is perhaps try to get a good feel. So if I go back to my log file, and if I take the locator step of that log file, you can see that these facet paths don't look right, do they? I mean, I would have thought serialization. Well, actually, to be honest, they don't look too bad. The question is really when you start doing the full path. So let's just keep going. All this stuff. Again, we don't really want to spend too much time here on this temporary stuff. Right, so we just add some more stuff here. Give us a lot of information now. Right, I'm not going to bother with things like include directory name and so on, not in the first go anyway. Relative include path. Facet. So let's call this includes path for Oops. And as you can see, this is all quite boring, but path include directory. But what this will give us is, hopefully, complete picture of what this thing thinks is doing. And some of these names, as you can imagine, are absolutely terrible. I mean, I'm not in any way condoning stuff we've done here. This is all stuff that was done quite a long time ago. So as you can imagine, some of these things don't really make any sense anymore. It was just learning, part of the learning experience. But we just need to make sure we can look at the log file and say we know which paths are being correctly calculated and why. So it's not really necessary. This is not really creative exercise as such. Provided that we got plenty of information, it should be quite trivial to then figure out. So of course it's going to create a lot of log. And to be fair, we probably should move all of this to trace, if I'm honest, because it's not really going to be helpful when we're just looking for debug stuff. Refactor, I'm just going to be lazy actually and just update everything to trace, because I don't think there's anything here that's worthwhile debugging. Right, okay, we're halfway there. Probably should put in a few more log statements, but I should think got a lot already. Let's just see what these new statements reveal. Right, there we are. So let's see the better picture that we got now. So project path looks sensible. The headers path looks sensible-ish, I guess. Templates path looks like we point in the right place. Output path looks like we have a space too many. And the OCDs amongst us won't be able to cope with that. And right, so let's see what you're trying to do. Make a facet path for registrar. Now we know for sure this is C++, the inclusion path is going to be Dogen drivability. Now see, that looks alright. The include path for C++ header, that looks good too. The prefix, the inclusion path prefix is Dogen variability. Okay. So I think up to here we look alright. So let's just keep scrolling and see, because all these paths are relative, so it doesn't look like we're making any really big mistakes here. If I go back to compilation, you see the problem, what we're seeing here is that we're creating a new file, and that file should have really been under include. So really what we really want to see is what is the full path for the header file. So let's just start looking for full paths. So here immediately you see that the full path to the include directory is not quite right. Should have been include. So if we now go back to our log file and try to understand. So we seem to somehow still not have the split mode done correctly. And I think it's peculiar because we were convinced we had done a fix for it. We did a fix, but we did the wrong fix. What we meant to do is say not populated. So in other words, if we do not have an override to the headers output directory, we should, if we do have an override, then we should be adding the facet directory. Okay, so there we are. Now, as you can see, this resolves parts of the problem. Now we have other problems. Now we're starting to have diffs. I think normally when we tend to have diffs is because we have files that have been placed in the wrong place. Now let's see what could be causing this. Default value override. So I think what's happening is that we're creating a file with the wrong name, and we are overriding the file that should have been with the right name. We should really have some checks to make sure we're not creating two files with the same name. We do, but I think at the moment we have got some, we changed those to warnings because there are some problems somewhere. As you can see, there's a few places where we got the strange warnings. See if I can see anything obvious here. Interestingly enough, we do have a lot of no diffs. Sadly, we have a lot of diffs too. As you can see here, what's happening is, if we scroll all the way up, see if we anything obvious. In fact, what we'll do instead is we just locate the first diffs, which is this guy here. Okay, so what does the diff say? Oh, actually, it is the contents of B and the diff. So I seem to have some kind of header. The rest have a namespace and pretty much nothing else. So the new files we are generating seem to be empty. We have namespaces, but and a little bit of decoration, but nothing else. The class has gone missing. Yeah, as you can see here. Okay. Now we can see clearly what's going on. We are overriding the forward declaration. Right, so this should be easy enough as well. So if we go to locator and look for postfix, presumably. Right, okay, cool. What's happening here is quite simply that forward declarations, postfix and forward declarations are not correct. Sadly, we don't seem to have anything here that could help us. So what we're looking for then is we're looking for the postfix, the artifact postfix. So let's just go back to the JSON file, and let's just go back to JSON modes, and let's look at the properties for not the facet but the archetype, and let's look for forward declarations. Now the problem we're having at the moment is this. In a forward declaration there's a postfix here somewhere, or should have been a postfix here somewhere. Not the backend properties, not the facet properties, but this, not the pipe properties either. We're missing something here. Where is just make sure I'm in the right place. So in the archetype properties, 4 declarations, 4 serialization, and in here the postfix is blank. Right, there we are. So there is no postfix being applied to 4 declarations, which is causing it to overwrite. So really, what we need to do here is to write a story that says generating validates that no 2 artifacts have the same ID. At present, it is possible to generate 2 artifacts with the same path, which is the physical ID, and then have them overwrite each other. This causes diffs that are very difficult to get to the bottom of. It would be better to fail with a validation that detects duplicates. Right, this is enough for us to remember what is going on here. We'll fix this at some point. Now, for now, what we need to do is just to solve the problem at hand. The problem at hand is going to be quite simple. It's just that the postfix is not being read, and now we know what that's going to be. It's going to be in the meta model properties postfix. Now, we are computing the postfix, and if we are computing the postfix, it seems to imply to me somebody is not using the computed postfix. Let's just check that we are. So postfix with facets, computed postfix, computed postfix, computed postfix, computed postfix. Okay, all of that looks good. Now let's just go back to so you see, both the computed postfix and the postfix are blank. Now, before we do anything else, let's just see how we're reading the postfix. Right, so this is after we're post-processing it. Right, so this is a bit worrying. No one seems to be handling the archetype postfix, which would explain why we haven't got one. Right, so interesting enough, we just seem to have skipped this altogether. I really would like to take this opportunity to yet again explain why it is so important to do things in an incremental manner. I mean, we could clearly have tried to do everything in one go, and instead of trying to update the legacy code, we could have been clever and then just assume that the properties would be populated correctly and so on. But because we didn't, not by sheer luck, but due to that decision, I guess, we are finding a lot of problems with the data on those properties. And these problems would have been quite difficult to debug, to get to the bottom of, had we waited all the way to the new code. So that is the feature group. There's going to be an archetype property somewhere. And this is the guy. Right, so I don't really like the fact that I'm not relying on defaults, but I'll just leave it at that for now. And just use that. Right, so now at this point in time, with a bit of luck, okay. The problem, of course, is the postfix is not a boolean. Get text content clearly. Right, so now then we are going to obtain the postfix, and the postfix will then enable us to start distinguishing between different types of things we've got. Okay, it's different kinds of errors this time. Right, so okay, fine. So we maybe not always have a postfix. So perhaps we need similar handling. I mean, I preferably dislike the fact that we're doing this ifs and buts. We should just make it optional. But such is life. Let's just continue the pattern. And now we're going to basically check to see if the postfix is available. If it is, we'll read it. All of this will be cleaned up. Right, so hopefully what this would now allow us to do is to okay, still a lot of errors, to be honest. I suspect we're not out of the woods with the postfixes, so I'm not going to waste too much time. I'm just going to go straight to the log file, and in the log file we did a search a second ago. Not quite sure what it was I was searching for. The locator, perhaps? No, it wasn't the locator. It was unified diff. Differ, yes, exactly. So let's see what we got here again. So, right, see here clearly we got the same problem really. We are not computing this correctly still. So, what seems to be the case at the moment is that we are still not populating the parts, the postfix correctly. So what we'll do is, instead of wasting any more time, we're now going to rely on our tracing infrastructure again. And in tracing, so if I look for variability, we shall have tracing here somewhere. And then in tracing, if you remember, we had this guy here. So this guy here contains the meta model, and what we would do is look for the artifact properties and then for declarations. Now, until we get the data coming through here, there's probably not much point of doing anything else really. So let's just focus on what this guy is saying, right? You can see clearly there is no postfix coming through, right? So I think herein lies our problem. Let's double check that we're not doing anything particularly silly. Postfix feature, right? It's called postfix. We're trying to obtain the postfix feature. Clearly he's finding it, otherwise this would throw. And then what we're saying is, if we have configuration, please read it to us, otherwise it will be blank. Now, okay, I think I know what the problem was. This is what you should have done, I should think. We should rely on the default. Again, there's a lot of stuff here that sadly does not make a lot of sense really. We should rely on the default value. We are going to implement this in a much more sensible way. But for now, what we've done is we have a set of overrides that give us default values for these things. Still quite red, so let's just return to our beloved JSON and make sure that okay, now you can see things are looking much brighter. Now, however, not quite out of the woods yet, because as you can see here, the computed postfix is not coming through, but at least there is a postfix. Now then, let's see why on earth we are not computing the postfix. going to be something very silly again. And it is simply the fact that no one bothered to compute the postfix. So we're going through the backends. From the backends we go through the directories. But there is no archetypes anywhere. So we probably should say something like this, I guess. So what we're going to say then is something like so we are looking through the facets. The facet is going to be pair.second presumably, and that will have archetypes. So really what we should really do here, I mean these names are already rather unclear, but let's try to make them slightly clearer. We already have a FCT here, so fine. So the facet will have archetypes, this will have a pair. Now the archetype ID will be the pair dot first, mmp dot archetype properties will do whatever this thing is, and then if we can just have another value here, and the archetype is not found. And we can throw right, so then rather confusingly, and then we have archetype properties, and the archetype properties will have, well, clearly we need some kind of way of getting the archetype and the archetype properties. So perhaps if we should say something like these names are absolutely atrocious, I'm afraid, but that's what we got in mode. So in fact, to be honest, we already know that this thing should be called AP, and this thing should be called FB, as well as that's called BP. So these are the properties. The archetype ID, that's the archetype, and now we can call this AP. Right, now then, we should now be looking through all the properties, all the archetypes, and updating them as well. Hopefully what that will then do is, excuse me, when we finally get to the end of this guy here, we should be able to look at this and look for forward declarations, and then the postfix. The computed postfix is sadly still not quite there yet. So why would the computed postfix? Let's make sure we are up to date. We are. Right, so somehow, now the problem here could be that simply that the facets, there could be another bug really. It could be just that we're going through the meta model properties, assuming that the facets have got all the archetypes in them, and we suddenly just found the problem, and actually there is a bug here. So we are assuming that the meta model has been populated correctly, of course. How can we double check that? Well, actually that should be quite an easy thing to do. We can go back to our log, and somewhere around here at the very top level there's a bootstrapping chain, that will contain... Well, let's look at what the bootstrapping chain does. Bootstrapping chain is... Oh, there's the meta model production chain. Okay, so if we just have a quick look at how the meta model looks like, this is a physical meta model. So what we expect to see here is we expect to see the backends, the parts, and the facets. Okay, so here we are. These are the facets, and now all we need to do is to make sure that if I look for the if I look inside of the facets for the archetypes, there we are, that the archetypes contain 4 declarations. If I just look for forward declarations, very nicely see there, primitive 4 declarations, and I would expect for it to have all sorts of stuff, but most importantly it is here. So it seems to us that the backend contains the facets contain so for example, in this particular case the facet is types, and types facet contains a number of archetypes, one of which is the 4th declaration. Oh yeah. Okay, so that's looking quite good. We seem to have the 4 declarations in the right place. We also know that the noise coming from downstairs. Might have to stop this in a second. But what we know at the moment is this: we know for sure that the meta model, which is where we are, the physical meta model, contains the backends. The backends contain facets. Now, as we've seen there a second ago, we clearly saw what's going on here. What happened here? Okay, I'm sure that this was clearly here a second ago. I must have deleted something by mistake. So we clearly know for sure that facets contain archetypes. Second. Right, so we are pretty sure that the facet archetypes, the facet have the right archetypes. At which point, what do? We then try to look for these archetypes inside of the meta model properties. If there's an error, we bomb out. So we will see this exception coming through. So the next assumption has to be that we did find the archetype. Actually, it's very interesting that we're using non-const. I can't quite see why this pair would be non-const. This should be const really. So there we are. We then look for the archetype properties, and then if we do find them, we compute the archetype. So let's just make sure we got the things the right way around. So it should be A, P, and P that computed postfix is copied across. So interestingly enough, we're saying here if p.postfix.empty okay, that's actually quite interesting. I think what we really mean is E, because what we're really saying is if, let's have a look, too much noise coming from downstairs. Right, so what we're saying then is we have the element, the meta model element, and we have the meta model properties. And what we're saying is, no, actually no, I think we got it the wrong way around. If the properties provide us with an override, then we should take the override. Otherwise, we should take the element. And that's actually correct. Sorry, that's actually wrong. That is correct. Okay, so that's fine. So then the question is, why is this not working for the elements, for the archetypes? So what do we know for sure? Well, we know for sure that the archetypes are present we know for sure there is no postfix at the archetype level, which is good. And then we know with a certain level of certainty that I look back at let's think about this then. What we need to now prove is that the meta model properties that we are getting in the log file, no, actually not the log file, sorry, if I go back to tracing and in the production, assembly, extraction, yes, right. If I look at this guy here, so we're trying to ascertain is whether we're trying to figure out here, probably should not. We're trying to figure out here is whether there is a problem with the way the meta model properties are being computed. I mean, if there is no postfix, then nothing good is going to happen really, so there's no point of proceeding. We know for sure that the meta model properties are, so what we've tried to do here, it's very difficult to explain in the video because you're trying to simultaneously keep lots of state in your head while at the same time trying to talk. We need to compute a set of meta model properties. Those meta model properties are computed on the basis of the state of the meta model itself. So if you think of the meta model as something that's kind of fixed, and the meta model properties as a configuration applied to that meta model, then the meta model properties are computed on the back of the meta model. It's all the physical sort of space. And what we're trying to ascertain first is the meta model correct? Because if the meta model, in other words, if the geometry of physical space is incorrect, there's no point in proceeding. That's the case, it's correct. The second step then is, what do we see when computing the meta model properties off of the geometry of physical space? And that's where we can easily go here and say, look at for declarations and look at the two properties that are relevant, which are going to be the postfix and the computed postfix. Clearly the computed postfix is not being updated. Okay, that's fine. So the computed postfix is not being updated, we thought so far, because we were not looking through the archetypes. So that's fine. So what do? We added a loop that says for every archetype in a facet, which we know they exist because we checked the meta model, we would like to then say locate the corresponding properties. So as we just said a second ago, one side is the fixed geometry of physical space, the other side is the configurability properties. And we are saying start with a fixed geometry of physical space, then find the corresponding configuration of that geometry, and then on that configuration of that geometry apply the computations that are required for the postfix. And so we know for sure that these things exist, the archetypes. We know for sure the archetype properties must exist, because if they didn't, this would throw. And therefore, the only thing that could be wrong here is that somehow we're not updating correctly the properties. Excuse me. So it's not entirely obvious where we're going wrong. But as we always do, we don't think too much about these things. We just ask the log to give us a hand. So let's just say something like processing backend, and then we could do something like bid, and similarly we can say processing facet, vid, and similarly you could say processing archetype. Right, now then, this is now going to enable us to confirm our suspicions that we are indeed processing the geometry of physical space, and all we need to do is to ensure the logging of this transform is correct. And that's this guy here. So do a quick grab, ask for this guy, and go to the log view. All we need to do is, so you can see here everything's coming through now. Right, so now then let's just see what the log file thinks we're doing. So, processing backends, C++, types, and then you see quite clearly, you see here, we are indeed going through all the guys as we expect. So that looks quite good. We are indeed traversing the geometry of physical space exactly as we'd expect. Now then, that's good news. What is not so clear is why we're not computing postfix correctly. So I'm just actually going to do a temporary log dump. Yeah, that could be permanent, I guess. So I think one should not really be worried about logging. I mean, early on in my career, I used to be very careful with logging. Now I'm actually quite liberal about logging. I think you should log as much as you need, really. The reason being that we seem to when you use logging, you use it because you need it. And systems are so fast these days that they can tolerate performance is not quite what it used to be. I mean, we used to have to do all sorts of crazy things in order to get systems to perform. But these days, we don't seem to particularly care about performance anymore like we used to. Very rare that you have to go down to the assembler level and so on. And it's much better to just be able to, when you need the information, to just get it by debug dumping everything in the log file, rather than having to go through lots of faffing around with debuggers. Okay, so we are seeing a lot of empty postfixes, interestingly enough, but I guess we'd expect that for declarations. So as you can see here, we don't seem... This is actually really curious. We seem to really truly be ignoring the postfix. It's very peculiar, really. Now let's think about this for a second. Could it just be that when we looked at the postfixes that we're seeing in JSON file, let's just go back in time a little bit here, and let's just look more carefully at JSON modes, slightly more carefully at those postfixes. Forwards. So we set a class 4 declaration and a postfix, and indeed it does. So it is not particularly obvious why the postfix logic would not kick in. So there must be some very subtle bug in this logic we're not seeing. So if the property has a postfix, take the property. Otherwise, take the postfix. So I mean, the only other thing you can think of is that we are not doing the not computing these things at the very end. we are. So that looks good. It's very difficult to understand why this would be happening, really. I mean, clearly what's happening here is that the property does not have a postfix filled in. I'm just feel tempted to just do a quick hack here and say original. I mean, we're now in the realm of quantum mechanics now, I think. This is really strange. We know for sure this thing is being filled in. It's just be a very, very, very silly mistake. Still some noise coming from downstairs. Let's put this on pause for a second. Okay, what's going on downstairs? Quite my attention. So where were we? We're trying to figure out... Oh yeah, we are in the realm of quantum mechanics where we don't quite understand what's going on here. Right, so what we're going to see, of course, here is that the original is going to have to be blank, really. I mean, what else could it be? Right, so you can see, exactly as expected, original is blank. Now we just have to understand why it is that we see the original is populated. At the end of the transform, halfway through the transform, it is not populated. One possible explanation for that is what could explain that, in fact. When we look at the output of this transform, you can clearly see it is populated. We know for sure that this guy here is copying it from this guy, from the main. So, in fact, I mean, this sounds really crazy, but what happens if we have a quick look at the, not the denominalized properties, but let's just try to go back to our transforms. The log. So what we're trying to ask is, we're relying on the denominalized properties. Let's just make sure that there's no strange differences between denormalized and non-denormalized properties. So we return to our byproducts directory in tracing. Right, so this gives us the result of the model population. We will, for a laugh, just rely on the metamorph property transform. So let's go back to the metamorph. Oh, sorry, I forgot to update the grids. Right, okay, so what we're trying to do here is to see archetype properties. So the archetype properties are these guys here. If I look for forward declarations, clearly the postfix is being filled in. We know for sure when we're filling it in. Like an easy insertion postfix here. And there we are, postfix is being filled in at the beginning when we are obtaining the archetype properties. Oh, actually, what I was going to ask, yes, well, there's only one container of archetype properties, so that has to be the right one. So this is actually very puzzling. Why is it that we think... Let's just make sure that we didn't print the wrong thing, in fact. One thing that you should always do, of course, when we're in a situation like this, we always... it's very easy to make mistakes. And because of that, what we should always do is not assume anything. It's very difficult. You think you're not assuming anything, but in fact you are. It's just the nature of assumptions. So when you do that, whenever there's this kind of problems, what you have to do is you have to just suspend the disbelief. This is going to be a very, very trivial typo. It's going to be a P instead of an A somewhere or something like that. The best way to solve this kind of problems is to not have any beliefs on anything, dump everything to the log file, and then just let the log file talk by itself. And then once you do that, it will become obvious where the problem is. So if I just keep going up a little bit. What we'll see now is, right, as you can see here, both of them are blank. That's very interesting. Why would both of them be blank, given that we know for sure the elements got properties? So which point do they become blank, presumably? That's the question one has to ask. Just double check here that we're not supplying... I'll tell you what's going to be happening here. Right, so there's two pairs here. So let's just call this the backend pair. I mean, as a sort of experienced programmer, one thing that we always tend to do is try to avoid reusing variable names. This is always a bad idea. Sometimes you become lazy. That's really where things tend to go wrong, particularly in template environments. So right now, let's just make sure for sure that interesting. Do we really mean? No, so this is wrong really. We should really basically say facet pair and this is not facet pair but an archetype pair. Okay, so this should make it a little bit more obvious. Now we seem to somehow, we know for sure the archetype value is correct. Okay, so the next thing obviously to dump here is going to be the archetype itself. Seems very strange. Like I said, this is going to be an absolutely horrendously bad typo somewhere, but for example, and here you are, obviously, and it's going to be very obvious. Apologies for this. I think the problem is talking and debugging at the same time is really, really not a good idea. And also using heavily templatized code, the combination is just really, really bad. I mean, it's not even heavily templatized code, but it's templatized code, I guess. Right, so now then, hopefully, okay, right, so this now is looking a lot better. Let's just remove some of this temporary logging. And let's look again at our compilation for the errors. So, okay. Interesting. Wouldn't expect 0 to be value, but there you are. So you can see here that the computed thing seems to be correct. So we are happy enough that this is right, so I'm not going to bother with that. Clearly the locator is doing something particularly silly. Scrap for locator for a second. Let's first look for 0, that's too many zeros. And let's look for postfix, there is none. It's interesting that we see lots of zeros in the diff. as if the postfix was 0. That seems to clearly be implying that we're confusing the postfix with something else. But then why don't we see that when we look at the log file? Clearly we should see here. Here we are, 0, bingo. So what is going on here? Well, perhaps what we should do is to say 0 must be coming from the postfix, without a doubt. The postfix of facets. Right, there we are. So let's have a look at these guys here. Make facet path. So ap.computer_postfix.empty. So this is really more stupidity going on, and presumably a copy and paste will ensure similar levels of lack of cleverness. Well, can't see anything pretty obvious there. Bit of luck, this will resolve, well, some of the problems at any rate, if not all. Okay, so we'll move over to the next set of errors. Okay, so look at the head, we can deal with that because we know it's one of ours. So what seems to be the problem with these guys here? So the problem here first, let's see how many errors you got. Not many, so that's good. So we're getting closer. Second thing is we seem to have a problem with the boost model. Now, the boost model, actually this path looks very, very similar to the right path. So let's have a look at what we think the right path is. See if that gives us some clues, right? So boost model include boost model. Okay, seems like no, that's correct. Then ODB package 1. Okay, no problems. So what's happening here is that the postfix seems to have been done incorrectly. Now that's most peculiar. Yes, that is most peculiar. So it must mean we have a bug. However, this postfix has been created now. So the postfix will be for facet, and it will be fragments if it is ODB, which is correct. Okay, let's just have a quick look where we are. Presumably we must have some tracing somewhere. If we look at this tracing and look at the metabolic properties, keep forgetting to refresh. Let's just look at ODB here. So this is the ODB feature. It has a directory name, but it doesn't have a postfix. Interesting that the postfix is blank, but the computed postfix is not. So, okay. Seems to me quite clearly that the postfix of the features are not being read correctly for the facets. So this is the postfix of the archetype. Clearly we've forgotten to update the postfix for the facets. Let's use the same approach that we've done there, which is to say most outer type ID is going to be the facet value. We shouldn't really call this ID really. Maybe V ID value. So hopefully so what do we decide here? We said facet is pair.second. Clearly here we are archetype feature group going through some indices with names. So probably should do something like what value? These are physical meta names. So reference to non-static. Okay, cool. Right, now then, hopefully this will then mean that we are now reading the facets postfix. I must say that it is 90% of our problems at the moment are just concentration problems. This kind of work, I may have to I think we're not going to really be able to record the whole refactoring of the formatables because otherwise this will take forever. The problem is this kind of work requires a lot of concentration, and it's very difficult to concentrate while you're talking and trying to read the code. So we will just complete the the locator update, and then just do a bit of work without recording, and then go back again, I think, to see if we can get a bulk of the work done. Now, what is the problem? We don't seem... Well, actually, before we ask any more questions, let's just go straight to our meta model, to our transform. Look for declarations. Look for ODB. Make sure that the postfix is still not being populated. Okay, cool. So clearly you see that the postfix for ODB is still not being populated. Which is correct, and exactly as I say, the problem at the moment is just concentration. We forgot the second part. This is really a big problem at present. They seem to be not focused really. And it's probably for the general kind of code that you're doing, it's probably alright actually to do sort of stuff, because it's not, it's the model is in your head and you know what you're doing. But the kind of stuff we're doing is just so complicated that we don't tend to have these models in our head so much. We keep forgetting about where we are, which makes life harder. Right, so here we seem to be having another similar problem. So in this particular case it's the extension. Let's just go back to where we were a second ago. Just somewhere in the boost model. And what we're looking for here is going to be something in source RDB. Actually, it doesn't look too bad. Ah, okay, we have some kind of postfix of options. This looks like an archetype postfix, if I'm honest. So I would expect to see it here. Interesting that if I don't, so well, okay. I guess the reason why we're not seeing it there is because there's a hack somewhere. So let's go back to the locator. Let's look for options. Here we are. So, alright. So let's look very carefully what we're saying here. I think we need to look at the head of this. Right, so what we're saying then is, if the archetype postfix is empty, so that looks alright, then if the facet, so this is really a massive hack, but okay, if the facet postfix is not empty, then we have a different behavior. This is all sort of historical of the lessons we are learning. Clearly this is really not a very good way of doing this. That's why we're generalizing everything from the meta model. So that's just all good. This is exactly what we needed to do. Right, so that solved a few of the problems. As you can see, we have a lot less problems now. What we'll do is we'll get rid of the head file that we have, just to get our diffs to go down. And right, now then, so the problem appears to now be test data. Let's look at lamb. So in fact this looks very similar. So let's have a look then. So C++ ref import lamb model. Notice that we have a backend directory here. Okay, cool. So we broke something else. We broke the backend directory. Now, if I look at my backend properties, look at the C# directory name, computer directory name, computer name. Okay, so what seems to be the problem at the moment is we don't seem to be reading. Let's go back to locator. Right, so if enable backend directories, let's look at PPP, make sure that it's correct as well. Enable backend directories is false. Now, we just have to bear in mind that we are not looking at the right test anymore, because the test we're looking at is passing now. So let's look for this particular test. And luckily, as luck would have it, it seems that we're failing JSON in dia, so I think we're really down to the last problem. Let's have a look then. Right, so what we'll do is we will, where were we? First tests. We need two things. We need not quite what we need to do. Right, so we need to get rid of all the debugging we're doing for this particular test. And then look for the new tests and debugging here. Tracing. It's horrendously slow, sadly, because as you can see here on Tremax, there's a lot of tests. Should probably avoid creating files with hundreds of tests, I think. LSP seems to get very unhappy when you do that. Let's wait a few more seconds. Hopefully we will get somewhere. Right, okay, so go anywhere other than here. Go back to our compilation. Right, now then, we'll run the test. We will go back to the log file now with, oh, I shouldn't have closed that, should I? See if we got anything with JSON notes. Tracing perhaps? Plenty of tracing. Right, so what we want to do now is to say, please look for the lamb model test. Lots of tracing as we wanted. Right, now then, so in here, we'll have exactly the same logic. We need to just look at this guy, and then hopefully, right, here we go, brilliant. So the enable backend directories is set to true. That looks brilliant. Backend properties, I've got the right extensions, they're computed. Oh, it is lovely. We now go to the locator and try to understand why we are not doing the right thing. Sadly, we probably could do it head again, but there you are. I don't even have to guess. That project path is being calculated incorrectly. I will assume that's the case. So let's have a look. We take the output directory. We compute the model modules, which is fine. We take the enable backend directories, which should know to be correct. We look at the backend properties, we find the backend ID, we know this is correct. Oh, this actually looks quite good. Slightly disappointed here. This looks exactly like what I wanted. Right, so that being the case, we have to go back to the log. And that is what we want. So let's see what locator thinks he's doing. Now then, start with project path. Oh, very nice. That's exactly what I would like to have seen. Now, let's just stop for a second and try to understand where the diffs were coming from. The diffs appear to be in the header files. Now, it could be, of course, that we're only looking at the very first few, but they appear to be in the header files. The project path appears to be correct. Let's take one of these header files. It's causing a problem. Interesting. Oh, okay, sorry, we are not looking at lamb. Right, so if I look at lamb, we would have something like this. Right, okay. Let's go to the top. Inclusion path, we don't mind. Full path area. So, full path is incorrect. It is missing the backend directory, so full path to C++. Hello. So we need the full path into directory. And that starts with headers.project path. Now, we know for sure that headers.project path is computed. we are, and presumably we... no, but there is a headless project path. Okay, sorry, I lost track of it here. So there's a headless project path. Presumably you'd have to take into account the project path. Okay, it seems like there's a bug here. In order to get the headless path, so now I'm afraid we're going to have to go back to head, because I think, in fact I'm pretty sure that we were taking the project path after computation as input to this chat. So let's see what the headless project path looked like in the past. So as you can see here, we're clearly supplying the project path as it was, and what we're saying is quite clearly is if the headless output path is not supplied, take the project path. Now if I go back to this guy here, I see the project path, and if you remember I told you I don't really like dependencies, but here there's a clear dependency. You put that guy first and then supply it. Now everything changed, right? So what we're going to see now is that the project path is indeed being computed, but we're not supplying it to the headless project path, which makes me think this guy here is doing something completely different now. So let's look at the logic as it was. If the user did not supply a path to the header, simply pointing to the project, and what do? We point to so in effect, to be honest, the problem was we this is just one of those things, right? We did not lie. The comments are slightly lying, really. What we say here is we're supplying to inside the project, but in reality we don't really mean inside the project, we mean inside of the back end. This should really be the backend directory. So really what we should do here is let's see what we should do. We should probably, we need to understand the backend directory. Do we have a backend directory? No, we don't. Right, so it's a bit difficult now. Well, let's just do the easy fix here. It's not very nice, but this is all one big hack at the moment. So let's just go with the easy option. And the easy option is to supply the project path as we did before. First we will just address the problems at hand, and then we'll worry about doing something slightly more sensible. I mean, this is all temporary code, so it does not need to be the cleverest. So I suspect we don't need MMP, probably need PPP, so that's fine. And then all we need to do is do what we did before. Typo. No, typo is just exclusive to this guy here. Right, so there is still a lot of confusion around projects and components and all that sort of stuff. It's fine. It has to be clarified at some point. It will be with a tidy up that we're going to do to the logical physical model. We just can't cope with it right now. So to recap, what was happening here was that we assumed that the directory supplied at the meta model level, which is in effect the project directory, was the same thing as the project path. And by the name, you could probably think that yes, it makes perfect sense. However, in this legacy code, we did all sorts of hackery. And one of the hacks we do is, if you look at the make project path function, one of the hacks we do is, if the backend directories are enabled, we add the backend to the project path. Now, that is just the way things used to go in the past. Now we have meta-model elements to represent the right bits of the hierarchy of the space. And we don't need to do all this hackery anymore. But in the past we had to. Now with this we finally managed to get test to go green. So what we'll do now is we'll just remove all the debugging. Let's do this quickly before. Oh, it took too long. LSP's upset already. Now, as you can see, I mean this clearly took longer than expected. This probably would have been half a day sort of work, ended up taking a whole day. We had problems with Emacs, I guess, but we also spent a lot of time dealing with small typos and issues like that. Clearly you should not really name your iterators after alphabet letters like A, J, K. But it would have been a bit quicker if we were focusing properly, I should think. Or this is my excuse anyway. Right, as you can see here, everything went green. We'll try to run the test again. So what we have achieved at the moment is we've managed, a long hard day, managed to get rid of properties that existed in the locator inside the textual CPP, move them to physical model. We validated that the way the data is being captured in the physical model is not correct, otherwise this would not have worked. All the tests are now passing, and the code generator is correctly generating everything as you'd expect. Probably should have done this without should have staged everything before I run that test, but it doesn't really matter. Right, so should say something like physical. I'll probably no, I'm doing this text CPP implement locator in terms of physical model properties. That's what we wanted to do. And then I'm not quite sure what this test is all about. One thing I do is if I keep a stash for too long and I don't know what it means, I just get rid of it. If it was important, I would know what it is. And so here what we want to do, so we started this around 4 o'clock. I'm sorry, forgot the actual time. 4:00. So around 16:01 we moved over to this task, and now we've achieved what we set ourselves to do. So have a quick look at the notes. Move locator configuration to physical model, using okay, we've done that. Create a location helper in physical model. Well, okay, sorry, we can't really close this story. Sorry, we're a bit whatchamacallit, trigger happy here, because all we've done is we are kind of still working on this story. To be fair, we still need a transform. So we've done this. We merged this. You can see how much work is still going on here. And now, what we need to do is the other side of this work, which is the transforms and so on. That's fine. We'll just agile backlog grooming. So what we'll do is to speed things along a little bit. Instead of recording everything, what we'll do is we'll implement the transform for the paths and so on in the updates, and let it really just implement that bit without recording it, to see if we can go a little bit faster, and then just do a quick video summarizing the work we've done there. So these videos now are going to be more summary rather than actually looking at the tasks themselves, just to see if we can speed things up a little bit. Okay, thanks for watching.